Welcome to another unit in the workbook Statistics. This time I'm going to talk about the so-called binomial distribution. Binomial distribution is one of those distributions, one of those discrete distributions, which is used relatively often to calculate probabilities if we are confronted first off with two different events and then taking a sample. Wanting to know how often does our particular event take place in our sample. Well, how could I imagine something like this? Well, think about there being a box like this. The box contains two types of chips, red chips and other colored chips, like blue, yellow, whatever. There's a relation in the beginning of 30 red to 60 other colored chips. Then we're going to draw one of those chips. We're going to check what the color is, and then we're going to replace the chip in this box. So in the end, after this draw, the box and the contents of the box, and most importantly, the relation of red chips versus other chips, did not change at all. That's the important aspect about the binomial distribution. I'm going to draw something, then I'm going to replace it. An event occurs, and then the event is more or less replaced. Or in other words, the event occurs, due to the hypothetical replacement, it can occur again. So that's actually two ways to recognize the binomial distribution. Either the replacement takes place, or the respective event can occur more than once. Another alternative to recognize whether we are talking about a binomial distribution is by taking a look at the relations here, at the probability of drawing one red chip. Here it's 2 to 60. So 1 in 4 chips is red. Here it's again 1 in 4 chips is red. So this probability of drawing a red chip did not change. So whenever the probability after each draw remains the same, then we are also working with a binomial distribution. Well, that's also the most important aspect, theory-wise, regarding the normal distribution, regarding how to spot when we have to use a binomial distribution. But let's take a look how we're going to work with this mathematically. Well, first off, we're going to need the probability. We need a probability function to calculate certain probabilities. That's what a probability function in this case is all about. The probability that of our draws, k of the draws, have the probability we want to have. So we're going to assume we have a sample of size n, and we want k of those n draws to have the specific property we're interested in. So that's actually what is written here. This is the probability that k out of a total of n drawn chips are red, if we take the example from the slide before. Then, in this part, we have how many possible combinations with, well, n chips are there where we are going to draw k chips that are red. So how many possible subgroups of k red chips in a draw of n chips are there? We're going to multiply this with the probability that we will get, with n draws, k red ones and n minus k not red ones. So that's the probability of getting the respective amount of red ones, the respective amount of draws with the probability we're looking for. That's the probability that we will get the rest being not of the probability we're talking about. Sorry, of the characteristic we're talking about. So that's the three parts our probability function is made of. Whenever we want to calculate a probability, we're just going to insert sample size which probability we want to calculate, and the probability that an event occurs, that we will draw one red chip. In addition to the probability, we could also calculate some statistical parameters like the expected value or the variance of the corresponding binomial distribution of a certain situation. The expected value in this case is simply number of observations in this case, or sample size, times the probability that an event occurs. And for the variance, we're going to multiply the expected value with the counter probability 1 minus p. Well, that's then everything there is I wanted to talk about with regard to the binomial distribution. I hope you enjoyed it. I say goodbye and see you next time.